Hello, this is Dr. J here with some more Commander X16 development. This might be the last major update to the Exist16 library before it's time to get it ready for release. The main attraction is going to be the support I've added for tile maps. But first, we have a few miscellaneous improvements to cover. I'll go over these in ascending order of significance and complexity. First, a commenter pointed out in a previous video something that's pretty obvious in retrospect. Rather than having a separate makefile in my build folder for running the application, I should just make a run target in the makefile in the root folder of the project so I don't have to keep changing directories to build and run the program. So I went ahead and made that change in the makefile, and now switching between building and running our project is a little more convenient. Next, I made some name changes to some of my files and functions. The sprite files and functions weren't very well named, because they're actually a bit more general than that, containing functionality that's useful not just for sprites, but also for tiles. So I renamed some structs and sprites to use the word graphics instead of sprite to better reflect their more general applicability. Functions and data structures that are still specific to sprites retain that naming convention. Third, I added a very simple enhancement to the text display routines. They now reference a palette shift variable that you can set before calling them. This palette shifts the text tiles before displaying them, which allows you to display text in different colors. I also experimented with all 16 possible combinations and created some macros with names that reflect the different possible colors. Some of the combinations yield colors that are ugly or hard to distinguish from each other, and I wasn't able to shift to a couple that would have been useful, like a nice pure blue. And although one of the combinations does yield a yellow color, it's a pretty anemic and desaturated yellow. Still, even if not every color is useful and one or two nice prime colors are missing, having 16 different colors to choose from when drawing a string on screen is a nice improvement, I think. Next, I thought of another function related to text display which, at least for my games, is not really a nice to have but is pretty much mandatory functionality. I added a function for replacing a substring within a string. The point of this is so that you can have placeholders in your strings to replace with a different substring, so that, for example, you could let the player name his characters and then display that name in your strings, or indicate how much damage or healing was dealt with an attack or spell within a larger descriptive string, and any of the other uses you could think of for replacing placeholder text. As always, we're keeping things simple, so this string replacement function only replaces the first instance of the given substring, and it does make the assumption that the replacement string is not longer than the placeholder substring that it's replacing. Even with these limitations, this should be a very useful and, for many games, downright necessary addition to our text routines. I know there are standard library functions that can accomplish this too, but by just including this ourselves, we avoid having to bring in the code bloat and increase the size of our executable that would occur if we brought in a whole standard library file just for the purposes of getting string replacement. Not to mention, remember that we have to use special arrays of raw ASCII codes because the CC65 compiler likes to encode strings with non-standard ASCII, which doesn't work with Exist16's text display routines, so there's that reason to make our own string replacement function as well. Finally, I rewrote my pseudo-random number generator. While I was building out the demo for this video, I discovered that the linear congruential generator I was using earlier had a problem common to a lot of pseudo-random number generators. The low bits would just get stuck repeating a particular value, making it useless for generating small numbers in a low range, which is going to be the main use case for random numbers in a lot of games. I experimented with a few different algorithms, but pretty much all of them exhibited that same behavior of getting stuck in cycles with low numbers, and all of them were also pretty slow and inefficient to run on an 8-bit CPU, so I ended up implementing my own pseudo-random number generator. As far as I know, this is a novel approach because I've never run into it anywhere else. What I did is create two tables, which each contain all 256 possible values for an 8-bit number, shuffled into a predetermined random order. You then provide two random 8-bit seeds using whatever means you wish. I still think getting the frame counter in response to the first instance of user input is probably the best way. and those random seeds act as indices into these two tables, so you have a random starting point into each table. Then, each time you ask for a random number, the generator XORs, which is to say exclusive ORs, the values at the current indices in these two tables together, and uses that as the current random number. It then increments one of the indices, and it only increments the second index for each 64 incrementations of the first index. This means it will generate 16,384 random numbers before it starts repeating in a cycle, which is more than a long enough period for any 8-bit video game. If you're wondering why I don't just have it increment every 256 iterations of the other one, which would give us 65,536 values before it repeats, it's because in my testing I discovered that it had a tendency to repeat not identical but very similar patterns more frequently if I incremented it every 256 cycles instead of every 64. I have no idea why that's the case, and from a purely theoretical standpoint, I don't see why it would be the case, but that was empirically demonstrated when I tested it out, and I found that the problem was reduced quite a bit when I incremented every 64 cycles instead. So, based on my testing results, that's what I ended up doing. Even if it does somewhat reduce the period so you start getting cycles earlier, I still say that with over 16,000 random numbers before you start seeing a cycle, that's good enough for any game that you're going to make on the Commander X16. Just don't use it for anything cryptographically related. This random number generator exhibits many desirable characteristics. It works with 8-bit numbers, it provides good randomness for any range of values you give it, and it's much faster and more efficient than the other algorithms I tried. The only real demerit is that the tables use up 512 bytes of memory total, so it's pretty space inefficient. But I think this downside is worth the trade-off of its other desirable characteristics. It's also only capable of generating 8-bit numbers. But if you need a 16-bit number, you can just call the generator twice, and then concatenate the two numbers it gives you with bit shifting, so that limitation isn't really an issue. With those miscellaneous updates out of the way, on to the main course. Exist16 support for background tile maps. I have three major pieces of functionality here. First, to help make setting all the different var values for the tile layers less error-prone, the tile's header has just a handful of macros that you can set to the desired values for your map base and tile dimensions, and then the tile initialization function takes care of the math to set everything up for you. This might not seem like a big deal, but I lost a couple of hours to debugging a problem from slightly messing up one of these values, so automating the configuration as much as possible is a good idea to make it less fiddly and error-prone. Aside from that, the only other thing you have to do is set your memory locations for your map bases and tile bases for each layer in the mem header file, and you'll have to manually check to make sure you're assigning enough space. I lost another hour here to debugging my own stupidity, because I momentarily forgot that each tile in the map base requires 2 bytes each, and I was just allocating enough space for 1 per tile, causing my map base to overrun my tile base and result in some pretty epic memory corruptions. So, be careful when assigning these memory addresses. Second is a function for scrolling the tile map and stopping the scrolling when you hit the edge of the map. You can activate the scrolling however you want, whether when the player character nears the edge of the screen, or the player moves the mouse to the screen edge, or in response to joypad input. However you choose to call it, having a function that takes care of scrolling the tile map and stopping when you hit the edge of the screen is a nice convenience. Finally, I added support for animated tiles, so you can have tile maps with things like animated water, trees and grass blowing in the wind, glowing lights, or whatever else you can think of. I needed to come up with a solution that was both processor and space efficient. So the way this works is pretty different from animated sprites. Keeping track of thousands and thousands of independent animation timers and frame trackers is definitely out given our tight memory limitations. So instead, the way it works is this. Unlike sprites, each of which animates on an independent timer, there's just one global timer for tile map animations. So all of your tiles will animate at the same speed, but you can define what that speed is. Second, there is a lookup table which defines which frames come after other frames in the tile animation sequences. The index into this lookup table is the same as the index of that tile in VRAM. The element corresponding to that index is the index of the next frame that comes after that one. If a given tile isn't animated, then the index and the corresponding element will be the same, which effectively just means that tile has a single frame of animation. Here's an example. I created this simple tile set with 4 tiles, representing grass, water, and mountains. The grass and mountains are indices 0 and 3, respectively. Neither of those are animated. The water is indices 1 and 2, and it's a simple 2-frame animation. Here's what the animation definition for these tiles looks like in the lookup table. Indices 0 and 3 correspond to the grass and mountains, and the next frame for each of those indices is also 0 and 3. The water, however, animates in a loop, so the next frame that comes after index 1 is index 2, and the next frame that comes after index 2 is index 1. This definition will cause the water tiles to loop back and forth between those 2 frames of animation endlessly. Once you've populated this animation definition lookup table, all you have to do is call the existAnimateTiles function for each iteration of your main game loop, and it takes care of the rest. I knew this would be a performance bottleneck, so I took pains to make it as efficient as possible. And in my testing, I found that it's running at full speed, so it seems to be fast enough, even though animating map tiles is a pretty heavy-duty operation. Before we move on to the usual demo, there's one more thing I want to address. There's one major piece of functionality that would be great to have which I haven't implemented yet: tile streaming. You've probably noticed that the size of tile maps we can cram into VRAM is pretty limited, yet old classic games like Super Mario or Sonic the Hedgehog have enormous sprawling levels that are definitely much larger than we could fit into VRAM at any one time. How do they accomplish this? Well, they do it by continuously loading new tile data into VRAM whenever the player nears the edge of what's currently visible. This is called tile streaming, and it's an essential technique for supporting scrolling games that have enormous seamless levels. While I would love to have this functionality, I haven't implemented it yet, and I'm not going to implement it for the first release of Exist16 for 2 simple reasons. One, because in order to make it performant and easy to use, it would be by far the most complex functionality to implement to date. And 2, none of my top game ideas require it. I would love to add functions to automate tile streaming to Exist16, but that's going to be functionality for another day, and I don't have an ETA on that. So if you have a game idea that requires tile streaming, for the time being, you'll have to implement it yourself. Even without tile streaming, the variety of games that can be built with Exist16's current functionality is pretty broad and robust. You can even make nice scrolling games by just using a pretty large tile map and having the player need to go through a door or have some other kind of loading zone in order to make each of the different game areas more discrete from each other. So there's still a lot of different things that you can do even without it. Still, of all the different features that aren't in the library right now, this is the only one that I feel is a bit painful not to have. But it is what it is, because I just don't feel up to implementing it right now, because I'm getting impatient to start working on my own games. Alright, so let's go ahead and show off the demo. So what this demo is primarily going to show is our tiling functions in action. We're going to show a little other stuff too. So I've defined a variety of strings here so that we can show a little bit of the new string functionality. This string says, hello name, with name in brackets, how are you today? And then placeholder is name in brackets, and replacement string is, well, we'll find out in a moment. Because we're going to run this through our string replace and replace the name placeholder with the name that we've put into the replacement string here. All right, and so here we've got a scroll map function, which we're just going to scroll the map with the joypad because it's a little harder to control with the mouse owing to the fact that the mouse has that weird schizo behavior when you first start up the emulator. So it kind of just goes all over the place. It does work with the mouse just fine. You can see how the code works for that. But for the sake of being able to control it a little better, I have just joypad input enabled right now. And so the way it works is we get which direction on the joypad is pressed right now, if any, and based on that, we set the exist camera change X or Y to a certain value, and then we call exist scroll camera, and after that we set the X and Y back to 0, the camera change X and Y back to 0. And with this, it'll take care of scrolling the map and making sure that it stops if it hits the edge of the map. And then I just put the code for displaying a game counter screen in the lower right into a function. And then I decided I might as well also display the camera coordinates, and so I put that in a function for displaying that in the lower left. And these are going to show our new palette shifting functionality. So the game counter string is going to be black, and the camera coordinate string is going to be red. All of this is going to be very hard to read against our tile background, by the way. So the point isn't that this is how you would actually display strings in a real game, because you wouldn't, because like I said, it's going to be very hard to read, but it's just demonstrating the functionality. Then we get to our main function, as always, turn on 320 by 240 mode, call our exist initialization functions. Then we load our graphic with our 4 tiles, they're the same ones I showed earlier, into memory, and then we grab each individual tile and copy them out of HiRAM into VRAM. This is all stuff that we've seen before multiple times now. This is something I was just doing for a test. It is not really necessary any longer, so I'll go ahead and delete that. And here's where we define our tile animation lookup table, exactly like I was describing earlier. So indices 0 and 3 just map to themselves because those tiles aren't animated. Index 1 maps to 2, so that when we hit our tile animation time trigger, why does this say sprite? That is not correct. I will fix that off screen. This should be a tile animation time trigger. So my bad there. Anyways, so once we hit the time trigger, we then reset our animation counter, and at the same time, we then look to see which tiles are at these current values, and then flip them to the next one, and that's how we achieve our animation. And here is where I fill the map with random tiles. Once again, for testing, I just use fixed random seeds, and these are going to be the indices into our random number tables. And then I tell it that I want a minimum value of 0, corresponding to the lowest index of our tiles, and a maximum value of 3, corresponding to the highest one. And then I call my new randomization function for every tile on the map to just randomize which tile every tile in the map is. I toyed with the idea of doing something fancier and creating what actually looks like a pseudo-realistic piece of terrain using a fractal generation diamond square algorithm. But this has already taken much longer than it should have because I made some dumb mistakes that took a really long time to debug. So in the interest of saving time, I'm just doing it in the most brute force, dumb, random way possible, rather than doing anything fancy. This is also testing code that we no longer need. All right, and then this is where we actually set all of the tiles in VRAM based on the random values that we populated in this loop. I have enabling the mouse commented out for the reasons just discussed. We set the width and height for the purposes of the camera. You can make these less than the maximum size of your tile map if you are rendering a map that is smaller than your maximum size. So I could, for example, set this to 512 and 512, and then the amount of map that the player would actually be able to scroll to would be half the size in both dimensions, so a quarter the size overall. And then we're going to display our greeting. So here's where I call the replace substring function. And then we enter our game loop, and We have our input functions there where we get the joypad state. We actually don't even need to get the falling edges because we don't use them in this demo, but I'll leave that in. Then we call scroll map. So based on the state of our joypad, that's what's going to scroll the map. We saw that function above. Then we call the exist animate tiles, animate map tiles, which is actually going to do the heavy lifting of doing all the animations for us. Then just more input stuff, and then we display the game counter and camera coordinates. So it's pretty simple, really. Not all that much to it. Okay, explanation's done. We will build our project and now use our much more sensible makefile that has a run target in it so that we don't have to change directories to run our program. All right, and so our greeting says, "Hi viewers, how are you today?" The placeholder name has been replaced with the name I gave it, which is viewers. And you can see we've got black text down here and red text down here. And we can see that our water tiles are animating on our timer. Everything is working. And now with the D-pad, I can scroll the map around. Let me get the mouse cursor out of the way. And we can see that once I hit the edge of the map, it stops. It does not let me scroll past the edge of the map, which is great because that would cause horrendous memory corruption, which is one of the things I had to spend a while debugging, to get it all working correctly. And as you can see, the pseudo-random number generator did a pretty good job of just filling the map with very random tiles. So I'm very pleased. If you look closely, you can see not actual fully repeating patterns, but you can see some parts where there's a kind of quasi-pattern that looks a little bit similar to something several rows above. It's not enough of a problem that I think it really impacts the usability of the random number generator or anything. But if you look really, really closely, you can see that there's just sort of little kind of pseudo patterns. But yeah, I'm very pleased with this. The randomness is good. The tile animation works and it's performant. The game is not slowing down at all. And the scrolling works. And yeah, I mean, everything is just working nicely and efficiently. So this, I think, will provide some pretty nice convenience functionality to help developers have an easier time with the tile maps for their games. And there we have it. All of Exist16's core features are now done and working. So what's next? Well, I have to release it for the use of the Commander X16 community. There's some more work to be done before that, like doing little bits of cleanup here and there, and by far the biggest task remaining is documentation. I want this library to be very well documented to make it as easy to use for people as possible. So that's what I'm going to be hard at work on. I'll definitely post an update video once the library is ready and available for public use. And after that, aside from maintaining the library, I'll finally get to start working on my own game ideas for the Commander X16, and I'll certainly continue to publish devlog videos chronicling the development of some actual games now that the library is complete. So, that's it for now, and I'll see you next time for some more retro game development goodness.